First, we are going to hide these reference designators. We don't need them right now. So left click into empty space, go into Properties panel, find Selection Filter, left click on all objects to unselect everything, left click on Components, we would like to work with components, press left button on your mouse, hold it down, select all the components, release the left button, and to hide designators, left click on this button which is here, okay? So hide designators, watch what is going to happen. Left click. Left click into empty space to unselect everything. Put selection filter back, left click on all objects, and perfect. I'm going to split my Altium because I would like to see schematic and I would like to see also PCB. If you have two monitors, you can do it this way. Just hover cursor over PCB tab, press left button on your mouse, hold it down and move it on the second monitor. Release the left button. This way you will have schematic on one monitor and PCB on the second monitor. Very, very useful. In case you only have one monitor, you can split your Altium this way, okay? Just hover cursor over this PCB tab, right click, and use this, split vertical. Here we have schematic, and here is the PCB. Also, double check if you have cross select mode active. Go into Tools, and double check this, what is here. When this cross select mode is active, there is a blue frame around this icon. At this moment, this mode is not active, there is no frame, see? So just left click on cross select mode, go into Tools and double check, okay? Now there is this blue frame, it means cross select mode is active. Perfect. When this cross select mode is active, then watch what is going to happen. So when the cross select mode is active, when you select something in schematic, for example, I'm going to select this symbol, which is here, watch what is going to happen in PCB. Left click, it is selected in the schematic and it is automatically selected also in the PCB. Same way, if you select something in PCB, watch what is going to happen in schematic. So left click here, and it is also automatically selected in the schematic. This is exactly what we would like to have. Before we continue, there is one more setting what I use a lot. Go into System Preferences, left click on this wheel or just right click into empty space and select Preferences. Go into PCB Editor, Board Inside Display, and uncheck this, Live Highlighting only when Shift key down. Okay, now if you are in PCB and when you hover over a path, then you will automatically see all the other paths which are connected together, okay? If I hover cursor here, there is some connection somewhere there, but if I hover cursor here, you can see all these paths are connected. These are connected together, okay? And if I zoom out, you can see where the things are connected. It is very useful. If you like, you can just keep the default setting, but then you always need to use the Shift key to be able to see these connections or these highlights. When we are speaking about system preferences, right-click Preferences, double check your settings in System, Navigation, Cross-Select mode. You may want to use exactly same settings as I have here, okay? Because if your settings are different, then your Altium may behave differently in cross-select mode. I'm going to show you an example. I'm going to check dimming, and I'm going to check zooming. Remember, zooming, dimming. Okay. Now, if you select something in schematic, then Altium will automatically zoom on the component in the PCB. Have a look. I'm going to left click on this chip and have a look what is going to happen here. See? And also, because we checked dimming, all the other components are going to be a little bit darker. And I don't normally use this zooming option because when I work in PCB, I would like to stay focused on the area where I work. I don't want to move Altium on the selected component. So that's why I use different settings. That's why right click preferences. That's why I uncheck this and I also uncheck this. Okay, now have a look what is going to happen, how Altium is going to behave. I'm going to zoom on our board, and when I select something, when I select this chip in schematic, I'm still looking at my board, but the chip is selected. And that's exactly what I would like to have. We are going to place our very first component into our PCB. Left click on the chip. Now left click into PCB. This is very important. You have to go into PCB. So left click into PCB. Go into Tools, Component Placement, and use this Reposition Selected Components. Because we have selected our chip in schematic, it was automatically selected also in the PCB, and now we would like to place it. We don't want to go and find it somewhere in the PCB. We just would like to pick it up automatically and then place it in the area where we are looking. So left click here. See, we have our chip. At this moment, because it is red, it means it is going to be placed on the top of our PCB, but we would like to place it on the bottom. So to move a component on the bottom, press L on your keyboard. Okay, now it is on the bottom, and place it exactly into middle of our board. So watch X and Y position and place it into 25 by 25, like this. Left click. To place the other components, we are going to use a little bit smaller grid. So go into PCB, left click on the PCB, press G on your keyboard and select 0.1 millimeter. You can always double check the size of the grid down here, okay? If I hover cursor over a PCB, you can see the grid is 0.1 millimeter. I'm going to hide these connections. These are actually kind of virtual wires which are telling you what paths are connected together. But sometimes this can be very disturbing, especially if you have like very complex board. There will be just a lot of these connections, and we can do the layout even without these wires, and especially now we don't really need them, so we can hide them. Go into View, Connections, and hide all. Much better. Because we are going to use this Reposition Selected Components command a lot, we would like to place a shortcut into this bar, which is here. So to place your own shortcut on this bar, simply right click somewhere here, select Customize, left click on All, and we are going to search for Reposition. Here it is. Okay, this is our command which we would like to place on the bar, and the bar is currently located here. Simply hover cursor over this Reposition Selected component, press left button, hold it down, and move it inside of these components. Maybe somewhere here. Okay, close. And now when you press right click on this button, place component, here is our shortcut. Go into our schematic, zoom in, and we are going to place these two components. Left click on the resistor, press shift, hold it down, left click on the capacitor. We have two components selected, and Altium remembers the order how we selected these components. So when we will be placing these components in our PCB, we will be placing them exactly in same order as we selected them. Have a look. Left click into PCB, right click on this placement. We are going to use reposition selected components. So what is going to happen when I click on these reposition selected components? We will be automatically holding the resistor which was selected as the first component. So left click on reposition selected components, zoom in, see we are holding the resistor. We would like to place it on the bottom side of our PCB, so press L on your keyboard and watch the connections, the yellow lines. Okay, these are the lines showing you what paths need to be connected together, and it will be maybe much easier if we rotate the resistor. So press spacebar to rotate. Now it will be easier to draw the layout. Okay, so always watch the connections because you may want to rotate the components for easier layout. To place the component, simply just press left click, and now we are automatically holding the second component what we selected, the capacitor. We would like to place it on the bottom side, so press L, and we don't have to rotate this capacitor because based on the connections, it looks like it will be easy to connect the capacitor with the resistor and with the chip, so rotation is perfect. If I press spacebar, we don't want to place it like this. Yeah, it would be more difficult for layout. So spacebar, and notice when I try to place it too close to the resistor, then there is this white number. Can you see it? When I try to place the capacitor too close, there is white number. It means there is a violation. There is a little bit easier way how you can very nicely see there is a violation, and we are going to enable this. So for now, I'm going to just place it somewhere, left click. And to make it more visible that there are some errors, press right click, go to System Preferences, PCB Editor, DRC Violations, Display, and left click on this solid override color. Okay, so if there is one of these violations which are checked here, then you will see the objects, they will have green color. Not many violations are checked which will be green, and one of them is this component clearance. That's exactly the violation what we can see here. You will see, I will show you. So press OK. Now when I try to place these components too close to each other, what will happen? They will have green color. See? Okay. And how we are going to fix this? We would like to place them maybe like this. We don't want to have any errors here. So what do we need to adjust? We need to adjust the placement rule. Go into Design, Rules, go into Placement, Component Clearance, left click here, and this is the value which specifies how close you can place components to each other. So I'm going to put here 0.099, and also I'm going to put here 0.099. Okay, and watch what is going to happen. No error between the components. Okay, if I try to place them too close to each other, there is error, but I can place them like this. Perfect. zoom in our schematic. We are going to place this resistor, left click, and we are going to place also this capacitor. Press Shift, hold it down, left click. We would like to place them close to pin number 24. Go into PCB, left click, and use reposition selected components. Notice our reposition selected component command is now directly on this bar. Yeah? When you press right click, you can see this our command, it doesn't have any icon. And this bar which is here, it remembers the last command which we use from this list. So at this moment, the command which is here is reposition selected components. So you don't have to use the right click. You can directly press left click and place the components. Zoom in. We would like to place it close to pin number 24. You can zoom in and you can see this is the pin number 24. But you can see it also because of the connections, the yellow lines. We would like to move this resistor on the bottom side of our PCB. So press L and place it maybe somewhere like here, left click. We are going to place the capacitor, press L, move it on the bottom side of our PCB. Watch the connections. We would like to rotate this capacitor, press spacebar, and place it maybe like this, left click. Left click into empty space to unselect everything. And I have not explained you how you can move components in the PCB. It's very simple. Just hover cursor over the component which you would like to move, press the left button, hold it down, and just move the component, okay? Like this. Release the left button. Perfect. Go into our schematic, zoom in. We are going to place more components. Left click on R7, press Shift, hold it down, left click on R6, C11 and C12. Left click on reposition selected components, zoom in, press L to place on the bottom side of our PCB, and where we are going to place this component. We need to place it close to pin number 12, but even without zooming in on this chip, we still can see where we can place it or where we need to place it. How do we see it? Based on the connections. Draw a circle around the chip and watch how these connections are jumping around. Or to be specific, only one of the connections is jumping around the chip. The other connection is still connected to one specific pin. This one. Okay, this pin, okay, watch the connection to that pin. See, it's still same. The other connection is jumping around. Do you know why? Because this one which stays here is the important connection connected to pin number 12. See, pin number 12. The other one is just ground, and ground is all around the PCB, so it's not really important where we place the ground connection. It is important where we place this resistor. We need to place it close to this connection, which is always fixed. We need to place it close to this pin number 12. So press spacebar to rotate and left click. Press L, place it on the bottom side. Again, draw a circle and watch which of these connections is going to stay same. Can you see it? This one here is staying always same. Okay, so we need to place this resistor there. Press spacebar to rotate. And left click. Press L. Again, draw around the chip. We need to place it somewhere here. Press spacebar to rotate. Press L. And we need to place it somewhere here. Press spacebar to rotate. Left click. zoom in. We are going to place this resistor divider which is here and this 0 ohm resistor. Left click on R13, press shift, hold it down, left click on R12, R17, go, left click on reposition selected components, press L, and we need to place it somewhere here. Press spacebar to rotate, and I'm going to tell you the exact position of this resistor. So place it into this specific location, which I'm going to tell you, because then it may be a little bit easier for you to do the layout a little bit later. So place this resistor, watch down here, okay? Place it exactly into 27.4 by 18.6, like this, okay? Left click, press L, spacebar to rotate, left click, press L, spacebar to rotate, left click, and move this resistor which is here, press left button, hold it down, and move it. Release the left button. Left click into empty space to unselect everything. We are going to place resistors around this second voltage divider, so select them like this. Left click, press shift, hold it down, left click, left click, left click, go into PCB, reposition selected components, left click, zoom in, L, place this resistor into position 26.4 by 32.8, okay? Watch down here where I'm going to place it. So 26.4 and 32.8, like this. Left click, press L, press spacebar, left click, L, spacebar, left click, L, left click, and move this resistor a little bit down. When you are doing placement and when you are doing layout, you can always just hover a cursor over a path and you will see where this path is connected. This is possible because, do you remember? Because we changed default setting, which is in PCB editor, board inside display, we uncheck this, okay? And always when you are doing placement, think how you are going to do layout, how you are going to connect the pins. And maybe we could improve something here. Can you see it? Tell me what we could improve. Watch how these pins are going to be connected. We need to route a track from this pin to this one. And we need to route also a track from this pin to this one. It means these two tracks, they will be crossing somewhere here. And there is easier way how we could do the layout. What can we do? If we simply rotate this resistor, then we can directly connect these pins here and this one here. So let's try it, okay? Hover cursor over the resistor, press left button, hold it down, press spacebar to rotate, and place it back. Hover cursor over this path and nothing is happening. I think there is a bug or something in Altium for a long time, or maybe it's a special feature, I don't know. But sometimes this highlight doesn't work. If it doesn't work, just move the component somewhere here and then move it back. Then it will start working. See, it's working again. And now watch what we changed. When I hover cursor over this path, we can simply route a track this way. And when I hover cursor here, we can simply route a track this way. So they are not crossing. We can very nicely do the layout on one layer. Perfect. That's exactly what we would like to have. Next, we are going to place these components around the power pins. And it's very important how we place them. So for example, we would like to place this C3 capacitor close to this pin number 19. To see where this pin number 19 is located on our chip, simply left click on the pin. Here it is selected. We need to place the capacitor somewhere here. Left click, left click, left click to select the capacitor. And also we can place these resistors which are connected to this capacitor. So press shift, left click, left click, left click, place or reposition selected components. Okay, press L, press space bar, left click, L, left click, L, space bar, left click, L, left click. We are going to place rest of the capacitors which are placed around these power pins. Left click on this one, press shift, hold it down, left click here and left click here. Remember the pin numbers, okay? 7, 6 and 3. And all these pins, they are located here. 6, 7, 3. So reposition selected components, press L. This one needs to be close to this pin, so left click, press L. This one needs to be close to this pin. Ignore the violation, we will move the other components a little bit later. Press L, and we need to place this one somewhere here, just left click. Now move this. Again, watch and think how you are going to do the layout, how you will be connecting the paths or the pins. Hover cursor over path, it is connected here, this is fine. This one is here, it is fine. This one is connected here, perfect. 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 Okay, we can move this a little bit up. Okay, this one will be connected here, here, and also somewhere here. And this one here, here, and up here, can you see it? So I'm going to move this maybe like here. So we can draw some lines or some tracks also this way. Okay. We can place the pull-up resistors. Zoom in, left click, press shift, hold it down, left click, and also select this. So shift, hold it down, left click, reposition selected components, press L. Okay, place it down here. We cannot really place this one here because these are important components. So I'm going to place it up here and then we will just route it. This one can be placed down here, see, but it can also be placed up here. This is very busy area, so we can place it here. It will be easier for layout. And also we can place here this one. Rest of the components we are going to place on the top side of our PCB. First, left click on this transistor, reposition selected components, and place it into position 14.7, watch down here, okay? 14.7 by 39, left click, select this transistor, reposition selected components, and place this one down here at, again, watch the position, place it into 14.7 by 15. Like this, left click. Select the rest of the components around these transistors. So capacitor, press shift, select also this one and also this one. Reposition selected components, place it maybe like this, place this one, have a look at the names of these paths. Okay, so I'm going to place it like here and rotate, place the capacitor maybe like this. Select also these, left click, shift, left click, reposition selected components, left click, space bar, left click, left click, and make it nicer so the position of the components look more symmetrical and your PCB or your board looks nice. Let's use these positions. Left click on this capacitor, left click here, change it to 38.6 and change this one to 33. Left click on this capacitor, change this to 38.6 and this one to 17, enter. Left click on this inductor, change this to 27.3 and change this one to 37. Left click on the next inductor, we are going to use 27.3 and 13. Left click on this capacitor, here use 16.6 and 44, and left click here, use 16.6 and 20. Zoom out the schematic, and only what left are the paths, and we would like to place again the paths on nice locations, so do it this way. Zoom in, select all the paths, left click, press shift, hold it down, left click, left click, left click, left click, left click, reposition selected components. And now if you would like to place this component on specific location, you can press J on your keyboard, select new location and write it here, okay? We would like to place this path on X5 and Y location set to 30. Enter, and do not move your mouse, because right now your cursor is at the location what you specified, 5 by 30. Press left click on your mouse. Perfect. And if you like, you can use J again and do it through this menu, or much faster way, we can simply just place it approximately somewhere here and we will manually adjust the position of the components. Now, this is very important. Many students make mistakes here. When you have a very simple component like this path, you have to be very careful if you are working with path or if you are working with component. When you simply just left click on this path, what we have selected, do you know? Based on this properties menu, you can very quickly see that we are working with path. Yeah? If I left click somewhere here, this is again selected, but this time this properties menu looks different. See? Now the J2 component is selected. Watch again, okay? I'm going to left click into empty space. Remember how this looks. And I left click on the path directly. See, this is different. These are properties of the path. If you change the location here, then you will be changing location of the path. That's not what we want. We would like to change the location of the whole component. So you need to left click somewhere here. Be sure you are working with J2 component. And here we can change the location to 520. Enter. Very simple way how you could work or how you can work only with the components. You can use selection filter, unselect everything, select only the components, and now every time when you just left click on this path, you will be always working with the components. So this is much easier way to place all our paths into the position where we would like to place them. So left click on this one, change the location to 45 by 14, enter. Change this one to 45 by 20, enter. Change this one to 45 by 30, enter. And change this one to 45 by 36, enter. Left click into empty space and change the selection filter back to default. So left click on all objects, be sure everything is selected. Well done! We have finished our placement. We don't need to use this split window anymore. Now we would like to see our PCB at full screen. So hover cursor over this PCB tab, press left button, hold it down and just move it here. Release the left button and fit board. To make it more comfortable to work with your PCB, we are going to create something what is called layer sets. A layer set is kind of a view where you enable just some layers which you would like to see. And the layer sets, or usually you create these layer sets for the views which you can use very often. For example, like top view. Okay, very often we would like to see our PCB from the top or from the bottom or from top and bottom. What kind of layers we would like to see for the top view? We would like to see the copper layer, the red layer, and we would like to see also the yellow layer. This is the outline or seal screen layer. Yeah. You can do it very simply. Just left click on this color. Or what you can do, you can press L on your keyboard. You will see this window. It's called view configuration, and here we can specify or we can define the layer sets. Because we are going to use it quite often, we can move it into this panel. Simply hover cursor over this view configuration name, press left button, hold it down and move it here. To create our top view or top layer set, left click on this button. This will add a new layer set. Now disable all the layers and enable top layer and the top overlay. Left click here, call it top, and save. Very similar way we are going to create the bottom view. So left click here to create new layer set. Disable the top layer, enable bottom layer, disable top overlay, enable bottom overlay. You can see what everything we have enabled. Left click here and call it bottom, save. The third view, what I very often use, is top and bottom view. So left click here to create new layer set. We would like to enable top and bottom layers. So left click here. We would like to enable top overlay and bottom overlay. And when we go to this top and bottom view, we would like to have the top layer active. So left click here, select top layer. Left click, name it top and bottom, and save. To see the views what we have just created, left click here and choose the view from this list. Top, bottom, top and bottom. There is also a different way how you can access these views. For example, very often when you are doing layout, you don't have this view configuration active. For example, you are using this PCB panel, yeah? And if you would like to quickly change the view, you don't have to go into view configuration. You can simply just left click on this LS button, layer sets button, okay? So left click here and select top or top and bottom. Or notice also these default views. Very often I use these all layers. When you would like to see all the layers in the PCB, just select this, okay? So these views are very, very useful. I really highly recommend you to create your custom views, at least top, bottom, and top and bottom views. When you are doing PCB layout, especially when you are doing layout of very complex boards, you may want to hide all the unnecessary objects which are not really needed for PCB layout. Because when you have very complex PCB, there is going to be a lot of stuff. So you really may want to think what is really necessary to see in your PCB. And one of these things what you may want to hide is grid. You don't really need to see the grid when you are doing layout. So let's hide the grid. Left click into empty space, go into properties panel, find grid manager, double click on this global grid and choose here do not draw and do not draw. See the difference, okay? I'm going to press OK and you will see how black this will become. Perfect. Before we will start with the layout, I would like to show you a few things which may be useful for you when you will be doing placement. I'm going to enable this bottom view and I will place the components maybe like this. So the first thing what I would like to show you is how you can align components. Yeah, I don't really use this align feature, but some people they do. And if you would like to place all these components in one nice line, you can just select them, right click, align, align bottom. If you would like to have the space between the components same, just right click, align, distribute horizontally. Or what can be also useful is use align and increase or decrease horizontal spacing. Yeah, see, now they are a little bit closer. I'm going to put them back, The second thing what I would like to show you is how you can work with more components at once. So if you would like to move all these components, just select them, and you need to hover cursor over one of these selected components, press left button, hold it down, and just move it. Okay. And the third thing what I would like to show you about the placement is when your placement is finished, what you can do, you can double check if the position of these components is optimal. And you can do it this way. Just select the components, press left button, hold it down, and you will see all the connections. And this way you can see where exactly is the best place for these components. We are not going to place them this way, yeah, because when you watch the connections, these connections are not the best. If I move it somewhere into middle, these are much better connections, yeah. If I put it here, these are not very nice connections, like this. Somewhere here is going to be the best place to put these components. Same on this other side, yeah. Watch, or I will select more components so you can see better. Yeah, we are not going to place it here. We are not going to place it, I don't know, here. Just find the best place for these components based on the connections which you can see. Okay, so I hope this can be useful for you. Before we start doing layout, we are going to also set some basic rules, and to get the values for the rules, you can check a website of a PCB manufacturer. For example, you can go to PCBWay website, and here you can check some values. Let's say we would like to see price and the values for some basic PCB like 100 by 100 millimeters, 5 PCBs, 2-layer PCB, quote now. And based on these numbers, we can then decide what kind of numbers we are going to use in our project. I like this calculator because you can very nicely see how big difference there can be in price of your PCB if you don't choose the right values. Especially have a look at these two values. These are the rules what we would like to set. Minimum trace width, minimum spacing, and minimum hole on our PCB. So at this moment, for this very simple PCB, 100 by 100 millimeters, 2-layer PCB, the PCB price or PCB cost is $5. Now, if you decide to use smaller holes on your PCB, let's say in our PCB, if you would like to use 0.2 millimeter holes instead of 0.3 millimeter, watch how this price is going to change. So I'm going to click on this minimum hole size 0.2 millimeter. $64. See? So when you are designing your board and you have quite a lot of space and you don't really have to use very small holes, then instead of using 0.2, maybe you would like to use 0.3 millimeter because it is much cheaper to manufacture. So I will click back on 0.3 millimeter. The price is again $5, and have a look what if you use smaller minimum width and minimum clearance between the tracks. So instead of 6 mils, let's say we would like to use 4 mils. Again, the price for the PCB increased from $5 to $64. Yeah, if we use 5, it is $41. When we use 6, it's $5. 8, it's $5. So for our PCB, we would like to use maybe this 66. And for drilling, this one is 64, this one is 41, and this one is $5. Minimum hole on our PCB, we would like to use 0.3. Let's have a look what is this in millimeters. 6 mils in millimeters. Go to Google. 6 mil to millimeters. Enter. It is 0.15. Okay, let's say in our PCB we will use minimum track width and minimum clearance 0.2 millimeter just to be safe. 0.2, 0.2, and minimum hole size 0.3 millimeter. Let's set these basic rules. Go back to our PCB, then design rules. Go into design rules, electrical, left click on this clearance rule, and here we basically set the minimum distance between tracks on our PCB. What number we are going to use? Do you remember? 0.2, enter. Then go to routing, left click on this width rule. Here we are going to set the minimum track width which we would like to use on our PCB. What number we are going to put here? 0.2. Preferred width, we can use 0.2, and the maximum width, I don't know, 10 millimeters. Enter. And also we would like to set this routing via style. So left click here and specify the minimum hole in our vias. Do you remember? 0.3. Press tab, 0.3, press tab, 0.3. And the via dimensions, we can use 0.6. Just left click here, you write 0.6, 0.6, 0.6. Press OK. Before we start doing layout, we would like to also adjust our stack up, because default PCB in Altium, it is just a 2-layer PCB, and we would like to learn how to work with more layers. So we are going to add some layers into our PCB. To change the stack up of the PCB, go to Design and use this Layer Stack Manager. This is how our current stack up looks. So we have top and bottom overlay layers. Then we have top and bottom solder mask layers. And we have copper top and copper bottom layer. Between the two top and bottom layers, there is the electricum. We are going to add 4 more layers, and I'm going to uncheck this because it can be sometimes confusing. If you use this, it will automatically add 2 layers, okay, because the stack up will be symmetrical. So uncheck this. Now, to add a layer, hover cursor over top layer, right click, insert layer below, and as the second layer we would like to use plane. Plane, it means this layer will be just solid copper. We are going to use solid ground copper. And on the plane, plane is a different kind of layer. On the signal layer you draw the tracks. On the plane you basically draw the spaces between the objects. I don't want to confuse you, but if you are not sure, always use just signal layers, okay? On signal layers you can draw the tracks. On plane, if you draw something, it means it will be space. We would like to add a signal layer, so right click on layer 1, insert layer below signal. We would like to add one more signal layer, so right click signal, and we would like to also add one more plane. Right click, insert plane. We are going to name the layers. Left click here, just write L1. Now arrow down arrow down, L2, arrow, arrow, L3, L4, L5, L6. When you will be using Altium Designer professionally, then you will be probably also talking to your PCB manufacturer, and once you get the exact stack up from your PCB manufacturer, then you may want to adjust also all these other values. But for our very simple project, we don't need to change these values. We only needed to add these layers, so we only created very basic stack up. It's fine, that's everything what we need. Don't forget to save the stack up and go into our PCB. We would like to see all the layers which are on our PCB. So left click on this LS button, select all layers. And if you would like to see only one specific layer, then use Shift S on your keyboard. Okay, watch what is going to happen. I'm going to press Shift S. Now, what you can see is the active layer, the red path on the red layer 1. All the other layers which we have here, they are grayed out. Or if you press Shift S one more time, everything will be hidden except the active layer. Yeah, if I click on layer 6, I only see what is on layer 6. Now I only see what is on layer 1. On layer 3, 4, there is nothing. And on layer 2 and layer 5, there is plain. Why? Because our layer 2 and layer 5 are plain layers. That's what we set in the stack up. When these layers are plain layers, it means everywhere here is copper by default. And anything what you draw on this layer 2 or on the layer 5, anything what you draw here is going to create a space. Okay, it's going to remove the copper. So the plain layers are basically negative layers. There is copper by default, and anything what you draw on the plain layer is going to remove the copper. On the signal layer, by default, the layer is empty, and anything what you draw on signal layer is going to add copper. And because by default on this plain layer there is copper, we would like to assign this copper to a net. And we would like to have ground planes on the layer 2 and layer 5. So left click on the layer 2, double click on the plane which is on the layer 2. So double click somewhere into empty space on our board and select here ground, GND, left click and OK. Also go on layer 5, double click into empty space and assign ground into our plane which is on layer 5. Press Shift S, go into the default view. What I found very useful during layout is to assign color to some of the nets. For example, let's say we would like to assign blue color to ground net. This is how you can do it. Go into PCB panel, left click on this PCB tab, or if you cannot see PCB tab, go to panels and select PCB. Then inside PCB panel, click here and select nets from this list. Left click on all nets, and in this list find the ground net here it is. Hover cursor over the ground net, right click, change net color, find our, I don't know, blue color. You can use any color you like. Press OK. And notice at this moment the ground in our PCB, it is still not blue. You need to check this checkbox, which is here. Just left click here. See? Now all the paths which are connected to ground, now they all have blue color. If you check this and if you cannot see blue color in your PCB, try F5 on your keyboard. Yeah, F5, F5. When you use F5, it can hide and it can show all the colors on your PCB. Okay, if you use more colors, for example, if I enable color for this FB1 net, I'm going to check it, zoom out. We have two colors on our PCB, the blue color for ground and this yellow color for FB1. If you would like to hide all the colors at once, press F5 on your keyboard. Yeah. Or if you would like to show the colors, press F5. F5. If you use F5, notice even if the nets or even if the colors are checked here, we still cannot see them in the PCB. You have to press F5 to enable the colors in your PCB. Okay, so if you check the color here, if you cannot see it, use F5. I'm going to uncheck this and I'm going to enable the bottom view. During layout, I very often use this feature. Have a look. Hover cursor, for example, over this path, press Ctrl on your keyboard, hold it down, and left click on your mouse. Now press square brackets, you can change intensity, like this. And because we use this Ctrl left click on this net, you can very nicely see which pins are connected together. And when you will be drawing the tracks, these pins, they still will be kind of highlighted. So even if you are doing layout, you still see what pins you need to connect. I know we have this second feature when you just hover cursor and you can see where everything is connected, but this is only at the moment when you are holding the cursor there. You cannot really use this during layout. During layout, you would like to use Ctrl, left click, and this way you can keep seeing what pins are connected together. So hover cursor, Ctrl, left click, and use square brackets to change the intensity of the colors. I'm going to use maybe something like this. If you would like to go into default view, press Ctrl and left click into empty space. We are ready to start doing layout. Yippee! We are going to start on the bottom side of our PCB. So we are going to draw only on the bottom side of our PCB. And at this stage of the layout, our main goal is to connect all the pins as quickly as possible. So don't worry about how this layout is going to currently look. We will improve all the tracks and we will improve the layout a little bit later. At this stage of the layout, our main goal is to connect all the pins as quickly as possible. Zoom in. We are going to start with this pin. Press Ctrl, left click. To route the pins or to draw the tracks on your PCB,
go to route and use interactive routing, or just press this button which is here. Left click on a path. Watch when the cursor will change, okay? You need to see the circle. It means the cursor snapped into center of the path. So left click and double check the width of the track. We would like to use 0.2 millimeter. Left click, left click, left click, left click, left click, left click, left click. As I said, don't worry about how it looks. We will improve layout later. Left click. This one is going somewhere on the top. So we just would like to place a via somewhere here. Left click, right click to cancel the routing command. And we are going to place via here. So left click here and change the parameters of the via. Change the diameter to 0.6, change the hole size to 0.3, and we would like to tint the via on the top and also on the bottom. So check here and check here. Left click, right click. Tinted vias, it means the color of your PCB is going to be also over the vias. Okay, so the green or blue or red color of your PCB is going to be over the vias. That's the setting what I normally use in my PCBs. So if you are not sure, just check this and use tinted vias on top and bottom. Zoom in. The next two pins are grounds, and because we have the big planes on layer 2 and layer 5, we do not really need to do anything special with these pins. Everything what we have to do is just draw a short track and place a via, which will then connect this pin to the layer 2 and layer 5. So draw short track and place vias here. For now, just ignore these small violations. We will fix it later. Next pin is +5 VCC. And there are many pins connected to this net. So what we can do, we can, a little bit later, we can draw a big polygon on layer 4 and connect all these powers on the layer 4. So very similar as for these ground pins, we are going to draw just very short track here, place a via, and then on layer 4 we will connect this a little bit later. Go to bottom, draw a short track, and place via here. Before we continue, I'm going to change one system setting. Do you remember Shift S? When I press Shift S, only the active layer is visible, all the other layers, they are grayed out. And when you press Shift S again, all the layers are hidden, only the active layer is visible. So this is the mode what I normally don't use. I'm going to disable this mode. So right click, preferences, PCB editor, board inside display, uncheck this, hide other layers. Okay. Now when you press Shift S, we are in the normal mode. Shift S, we are in the grayed out mode. Shift S, normal mode. Okay, this is what I normally use. I'm going to switch to top and bottom view. Press Shift S, and because we are doing layout on the bottom layer, make this layer 6 active. Left click here. This is the kind of view
what you may want to use during layout. Why? How this kind of view can be useful? For example, when you are placing vias on the bottom side of your PCB, you would like to be sure there is no path on the top side. Yeah. Also, you can very nicely see if some of these signals are connected also on the top layer, you can very nicely see where they are connected. For example, if I hover cursor over this signal, see, it's connected here on the top layer. And because it is grayed out, it's not going to be so disturbing. You still can very nicely see the bottom layer. Yeah, when I left click here, you very nicely see the bottom layer, but if needed, you also see the top layer. When you are doing a layout of the middle layers, you may want to use this kind of view, signal layers, okay? So when you are doing layout, for example, on layer 3 or on layer 4, you may want to use this kind of view, signal layers. For top and bottom layout, you may want to use this kind of view. The next pin is connected here. Left click, left click, left click, left, 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 right click. This one is connected on the top, so just place a via here. This one is simple. Okay, this one we need to connect on the bottom and then it will go somewhere on the top. Press spacebar, you can change the direction. If you don't like the direction how the line is drawn, you can use spacebar. Yeah, it will adjust like this. Watch, see? And we need to place a via here somewhere. Okay. This one is connected to the top. I'm going to move it a little bit like this. This one is very simple. You can make it a little bit nicer, like this maybe. Okay. This one we can connect here and then use a via and connect these two on a different layer. So I'm going to draw it like here. And down here I just place a via. If you would like to move a track, just hover cursor over the track and hold the left button on your mouse and just move it. The next pin, this is a simple one. This one is connected on the bottom and then it has to go on the top. Oops. Press backspace, you can go one step back. Let's say like this. Okay. Again, press space bar. You can play with the angles which are suggested. Okay. This pin is unconnected. You can see there is no net name on this pin. It is just a pin number or path number. This one is ground. You can see it based on the blue color. And this one, we will connect these two paths on the bottom layer, and then we will use different layer to connect these two paths with this one. So just draw a track here. And use a via. Okay. Very similar. We will connect these here, and then we will connect the other pins on different layers. So just go here, place via, next pin, we can connect it here, and then we can go around these components and connect it also here. Maybe like this. This is simple one. When you are doing a layout, also watch what kind of signals you are routing. Okay, this is enable LDO. This one is not really important. It does not really matter how we are doing layout of this signal. But some signals are really important. Like this next, +5 VCC. And we mentioned this signal is going to be connected on layer 4, but I think this connection is important. Little bit later we will check this connection in the schematic. For now I'm just going to connect it like this. Okay, I will connect it like this. This is simple. The next pin. This one will go up here. So just place a via. Next one is ground. Again, we will put here a via. There is no space. Maybe we would like to move these resistors. Press Shift, hold it down, select also this one. Move it a little bit up. I will also move this. Okay. Perfect. And notice how these lines are automatically adjusted. See? They are pushed. And it is because I'm using this hack push obstacles. Down here, can you see it? When you are doing a layout, there are different kind of modes which you can use in this interactive routing. Press Shift R, you can change these modes. When you press Shift R, watch what is going to happen. See? Stop at first obstacle. It is different kind of mode. It's just doing nothing. It just stops. See? It doesn't allow me to route. Press Shift S or Shift R. You can change to auto route. I don't use this. Press Shift R, auto route, Shift R, ignore obstacles. So now I can route even if there are errors. Shift R, walk around obstacles. This is what I sometimes use when I'm finishing layout. And press Shift R, push obstacles. This is what I use a lot in this kind of stage of the layout. So there are a couple of different modes. So I'm going to cancel this command. Right click, Preferences, go to PCB editor and interactive routing. These are all the modes which you can use during interactive routing. And because I don't use all of them, I'm going to uncheck this auto route. I'm going to uncheck hack and push. And these are what I normally use. So ignore, push, walk around, and that's it. Okay. Start routing, push obstacles, perfect, and just finish this layout. And because we were speaking about these different routing modes, go back to System Preferences, right-click Preferences, go to PCB Editor, Interactive Routing, and uncheck this, okay? Do not allow Altium via pushing. This is so dangerous, especially when you have very complex layout. If Altium starts pushing the vias in your layout, it can make a lot of mess. Okay, so just uncheck this and press OK. Let's go back to our layout. we have connected this path. The next one is already connected. We just need to place a via here, which we will connect with this via a little bit later on different layer. Okay. And the next path is this one, and it is going to be connected on the top. Zoom in, place a short track somewhere here, and place a via. We would like to connect this via to UGate 2. This is UGate 2. Select this, right click, and move it a little bit like this. Sometimes when you are moving vias, you would like to have more options. Notice, at this moment when I try to move via, it is always connected to the track. But for example, when you are doing very high density designs, there are situations where you would like to move just the via, and then a little bit later, you will figure out how to connect this via. And that's the reason why I sometimes change the default settings, right click, preferences, go to PCB editor, interactive routing, and I'm going to change this. Selected via track, use move. Okay. Now watch how this behavior of Altium have it changed. So if you select a via, and when you hover cursor over the via, press left button on your mouse, hold it down, you can move just the via. Okay, you can place it somewhere and then connect it. It may look like why I would like to use this, but I'm telling you, sometimes this can be very useful. So I go back. If you unselect the via, when you hover cursor over the via, press left button, hold it down. You just can move it and it will stay connected. So you have two options now. You can move it together with the track, or you can move it just without the track. Same for, I'm going back like this. Same for tracks, okay? If you do not select track, you can move it and it will stay connected. Or if you select a segment of the track, you can just move the segment like this. This is usually not very useful, but you know, it's same setting here. So yeah, just I normally don't need to move just the segments of the tracks, but this is very useful for vias. That's why I use it. The last pin of our chip is this one, and it is going to be connected on the top layer. Everything what we have to do is just draw a short track here and place via. Let's have a look what other pins on the bottom layer are still not connected. We are going to start here. Press Ctrl, hold it down, left click. And we are going to place this short connection, or it's called fan out. We are going to place it on all these pins. To make it easier and faster, we are going to copy this fan out. So select this, Ctrl C, left click here. We would like to hold the fan out in the place where we will be putting them on the path. So we would like to hold it here. It's easier to place it on the path. Yeah, rather Ctrl C. If I copy it here, we don't want to hold it here. It will be difficult to place it on the path. So Ctrl C, left click here, Ctrl V, place it here, Ctrl V, Ctrl V, Ctrl V, press spacebar to rotate, Ctrl V, Ctrl V, rotate, Ctrl V, Ctrl V, perfect. Left click here, Ctrl left click, Ctrl V, The next path, press Ctrl, hold it down, left click here, and place fan out on all these ground paths. Ctrl V. And we also need to place via here. And usually into exposed path you place more vias because the exposed path is very often also used to take heat away from the chip. So just left click here and place some vias here. Double check if you have connected all the paths on the bottom. If you missed something, don't worry, okay? We will find it a little bit later. But if you see something, you can connect it, for example, here. And also, we can very easily clear these errors. Just move it a little bit. Perfect. We can go on the top layer, left click on this layer 1 tab, and we can connect the paths which are here on the top layer. Don't forget about our mission. Do you remember what our mission is? At this stage of the layout, our mission or our goal is to connect all the pins as quickly as possible. We don't care how these tracks are going to look. At this stage of the layout, we don't care how high currents are going to flow through the tracks. At this stage of the layout, we only care about connecting all the pins as quickly as possible. So let's do it. Let's connect all these pins on the top layer. Hover cursor over this first path. It is connected down here. Zoom in. We need to create a fan out. Left click, left click, left click, right click, place a via. We will connect this a little bit later on different layer. These are connected to ground. So press Ctrl, hold it down, left click. I'm going to copy this. Left click, shift, left click, Ctrl C, Ctrl V, and I'm going to place it here, here. Many pins are connected to ground. Okay, that's too big path. So I'm just going to draw a new connection here. Of course, this is not the proper connection for this path. We will need to improve it later, but we just would like to connect everything. Okay. The next pin is connected down here. Zoom in, select Ctrl C, Ctrl V. We will connect it later on different layer. This one is connected here. Ctrl V. Connect it here. Ctrl V. These pins are connected all together and also here. So very simply just draw it like this, and also we need to place via here. Okay, this one. Okay. Connect these paths. It is connected also down here, so place via. And connect also these. We will need to connect this track also with this via, and we will need to connect this track also with this via. So place a via here and also here. Wow, it looks like we have routed all the connections or all the pins on the top. What are we going to do now? What would you do? We have routed the connections on the bottom side of our PCB. We routed the connections on the top side of our PCB. We are going to continue in middle of our PCB. Go on this LS button, left click, select signal layers, and we are going to route rest of the signals on layer 3 and layer 4. Left click on layer 3, go to view, connections, and because we have routed a lot of connections, almost all of them, what we can do, we can show all the unconnected nets. If you use this feature, if you show the connections when your layout is not done, or when you show these connections at the very beginning of your layout, and if your board is very complex, it can make the layout a little bit harder for you because there will be a lot of wires everywhere. But at this stage of the layout, when we are almost finished, when almost everything is connected, this can be very useful. So just go to view, connections, and show all. We would like to see what is still not connected. Our board is almost done. These are just like really few connections what we need to connect. We are going to start with the most complex connections. These are simple. These are just, two vias connected together. But this one looks like the most complex one. So control left click on this one, zoom in, and it is plus 5V VCC. Do you remember what we said about this plus 5V VCC? We would like to create a big polygon, big copper area on layer 4 for this plus 5V VCC net. And when I'm doing layout, in this first stage of the layout, when we are connecting all the pins, I don't really use polygons, because if you draw polygons, it is sometimes quite hard to work with them. If you would like to adjust the shape of the polygon, it's quite a lot of work. Also, sometimes you cannot really see through the polygons, and if you place vias, there can be violations with the polygons. So what I normally do in this stage of the layout, when we are connecting all the pins, I simply use tracks to connect these vias. And later, when we will be improving the layout, we will draw the polygon around these vias. You will see. Okay, so at this stage, instead of drawing a big polygon, big copper area on the layer 4, we are going to simply just draw tracks and connect all these vias together. Left click here and connect them. almost finished. Okay, and we can go on layer 3 and finish our layout. Zoom in, be sure you are on layer 3 and connect the vias where you see these unconnected connections. Left click, left click, left click, this one, here is something unconnected. We can connect these two. Don't forget, this is on a different layer. It is on layer 4, so we can simply just draw this way. We can go around with this. Okay, connect it. Almost finished. Here is one, and one more is here. This is between this via and this one, which is here. By the way, sometimes when you use the gray out mode, some of the layers, they still can be quite visible. Notice this layer 4, this track which is here. It's still quite strong and it can be disturbing when you are doing a layout on the layer 3. So to make this a little bit less visible, you can try to change the color of the layer 4, or there is better way how you can do it. Go into preferences, right click into empty space, preferences, go into PCB editor, board inside display, and instead of using gray scale other layers, you can use these monochrome other layers. So I'm going to uncheck this, check this one, okay. Now when you press Shift S, notice how big difference it will be. Especially look at these tracks which are routed on layer 4. Okay, I'm going to press Shift S. See? Now you can very nicely see the tracks on layer 3 and everything else is in background. So this can be sometimes very useful. If you would like to go into the normal mode, press Shift S on your keyboard. And if you would like to go back into the monochrome mode, press Shift S on your keyboard. Okay, it looks like we have connected everything, but to be sure, we are going to run design rule check. Do you remember how to run design rule check? Go to Tools, select Design Rule Check, and this time we would like to check all the kind of rules. So left click on Rules to check, and we are going to enable all the rules. So we would like to check for all the kind of rules. Right click here, Batch DRC all on. Batch DRC, these are the rules which are checked when we press this button here, and the rules which are here, they are checked online when you are doing the layout. So we are going to use this button. We would like to check all these rules which are here, except the rules for signal integrity. So left click here, right click, Batch DRC all off, and also we don't want to check the rules for test points. We don't use this. So right click here, Batch DRC all off. If you go on rules to check, everything else should be checked, okay, except these test points, fabrication, and these signal integrity rules. Looks okay. Now we can run the design rule check. Press this run design rule check button, left click, close. And there are some errors, 10 rule violations, clearance constraint 4 errors. So there are some objects which are too close to each other, and unrouted net constraint. So we have some nets unrouted, 2 errors. Power plane connect rule, 4 errors. Let's have a look on our PCB. Let's have a look where these errors are located. One of the best ways how you can check the errors and violations on your PCB is go to panels and select this PCB rules and violations. Left click. I'm going to move this into our panel, so just hover cursor over PCB rules and violations, press left button, hold it down, move it here, and left click on all rules. Down here you will see all the errors, all the violations which are on our PCB. If you would like to see specific violations for specific group of rules, for example, you would like to see only the clearance violations, left click on this clearance constraint. Yeah, these are our clearance violations. And here you will see the rules which are used for these are the rules which are used when you are doing design rule check for clearance violations. Double click. This is the rule what we set. Do you remember? We don't want to have anything closer than 0.2 millimeter. And there are some places on the PCB where some of the objects are only 0.1 millimeter from each other instead of 0.2 millimeter. I'm going to close this. And we would like to see where are these places, where are these errors. So left click on this first violation. Can you see what the problem is? These two vias are placed too close to each other. Sometimes the violations or the errors are not so visible. So sometimes you may want to hover cursor over this violation and read the full description of the problem, okay? Or double click and read where exactly the violations are located. Check this position and check the layers where the violation is happening, because sometimes you may need to enable the layers here. They may not be visible, okay? Or what can be also useful is use this highlight button. Watch what is going to happen. See, everything else is grayed out, only the problem is still green. See, these two vias. Okay, how are we going to fix this? We just need to move the via a little bit further. Watch what is going to happen with the violations. I'm going to move this via, maybe somewhere here, and the violation is gone. Now these two vias are not green, only these are still green. If I left click here, so this is the second problem. I'm going to move this via a little bit further, maybe like this. And okay, all the clearance violations are now gone. So we fixed them. Don't worry about how the layout looks. We will fix this a little bit later. Go on all rules and check also the other violations, this one. Sometimes may happen that if you have in your PCB a place which is causing violations, this place can cause violations in different kind of rules. And what can happen if you fix one kind of rules, for example, if you fix clearance constraint rule by moving these vias, sometimes can happen that the other violations which were in same place are not automatically cleared from the list. So what is very useful to do, always when you fix a bunch of violations, rerun the design rule check. Okay, that's what we are going to do now. Watch what is going to happen with these violations. Maybe they will disappear when we rerun the design rule check. Go to Tools, Design Rule Check, and run Design Rule Check. Can you see it? Rule violations, 0. If we go into our PCB, there are no violations listed when we select all rules. Well done! Yeah, you done a great job. I need to tell you this because we finished the first phase of PCB layout. We have connected all the pins and we cleared the violations. We are ready to move to the next phase of the layout. We are going to improve the layout and finish it.